me clearly? My voice is clear. Just raise your. Okay, it's all right. So today is our week 4, and we are going to discuss today. So let's wait a minute. I'm going to upload the PowerPoint slides. Yes, there is a voice. Wait a minute. I'm going to upload the PowerPoint slides. That's why I'm telling you. Wait few minutes. So today we are going to discuss these things. First of all, we will discuss the determinants, minors, and cofactors. After that, we are going to discuss how to evaluate the determinants by the cofactor expansion. And then we will discuss the determinant inverse of the matrix using the adjoint, and then after we will solve the linear systems using the Cramer's rule. And then we will discuss how to solve the determinant using the row reduction method. So these things we will discuss today. So we start one by one. Say that there are 3 major topics in this module: the determinant by cofactor method, evaluating the determinant by row reduction method, and the third property, that is properties of the determinant. Dear Adil, I already upload these PowerPoint slides, and maybe you can see these for week 2 PowerPoint slides on the blackboard. And these slides I will upload today in the evening, and you can see these slides up to tomorrow evening. So every week I upload all the slides on the blackboard. So in the determinants, I told you today, so we discuss these things in today, determinants. So first of all, the definition of the determinant is: a determinant is a real number associated with a square matrix. it must be a square matrix. If there is not a square, then we say that it is not a determinant. It could be a matrix. So this is the property of the determinant, that it must be a square. Yani 2 by 2, 3 by 3, 4 by 3, 4 by 4, and 5 by 5. This type of matrix, then we say that it's a determinant. So a determinant of this is a 2 by 2 determinant is a real number defined by determinant of A will be AD minus CB. And we multiply this and CB. In this way we can multiply, and whatever the result we got, that's the determinant. That's the value of the determinants. So determinants are commonly used to test the matrix is invertible and to find the area of a certain geometric figure. So most of the time we will find the determinant by using whether the matrix is invertible or not. Invertible, as I told you in the last lecture, the condition of the matrix to find the inverse is, if we can find the inverse of the matrix, then the condition is the determinant of A must not be is equal to 0. If this condition is valid, then we can find the inverse. If this condition is not valid, then we cannot find the inverse of the matrix. So this is the definition of the determinant. So it is written here that I told you right now. It's written here: a square matrix is invertible if and only if the determinant of A does not is equal to 0. So this is the theorem, and only when we can find the inverse, when the determinant of A does not is equal to 0. So determine if A inverse exists by computing the determinant of the matrix. So there are two matrices are given, the matrix A and matrix B is given, and tell me whether the inverse is exist or not. So what we do first, we will directly just check whether their determinants. We will check their determinants. Just 5 multiplied by minus 1 and 4 multiplied by 9. So we multiply 5 multiplied by minus 1 and 4 multiplied by 9, we will get a minus 31. So it is not 0. So it means that A inverse exists. A inverse exists. Meaning is that we can find the A inverse. If it is 0, then what is the meaning of this? We cannot find the A inverse. But here it is not 0, so it means we can find the A inverse. So in the last week, I showed you several examples of this type of things. So maybe you remember. Similarly, the other example is, it again says that there is a determinant is given, and we will multiply this row, and in this way we will multiply this. There is a 9 multiplied by minus 1 and 3 multiplied by 3 minus 3 multiplied by 3, that will be is equal to 0. So it means that A inverse does not exist. Meaning is that whenever this type of things happen, then we directly say that the A inverse does not exist. We are not going to proceed further. We just stop the process and says that A inverse does not exist. So now next thing is, what are the minus and cofactors? So minus and cofactors are also very useful to find the determinants of the matrix. So there are several roots of the minus and cofactors. Let's discuss. The definition of the minus is, the minus is denoted by Mij. Mij for the elements Aij is a square matrix of A is a real number, computed by the performing the following steps. So step number 1 is delete the ith row and the jth column from the matrix A. So step number 2 is Mij is equal to the determinants of the resulting matrix. And next, the cofactor denotes by Aij. For Aij, the cofactor will be equal to minus 1 to the power I plus j and multiply by Mij. So that is called the cofactor. So there are two things. One is minor and the another one is cofactors. So example of finding the minus and cofactors. So the question is given A is equal to minus 804, and there are 3 by 3 matrices given, and you have to find the minus as well as n cofactor. So let's restart. So minus 1, to obtain M11 begins by cross out the first row and first column. So first of all we take this element minus 8. So whenever we take this element, we will cross the whole row and this whole column, and rest of the material is called the whole rest of the material is called the minor of this element 8 minus 8. So we write here, so we will multiply this minus 6 multiplied by 5 and 7 multiplied by minus 3. So in this way, when we multiply here, that's where we will get determinant of B is equal to minus 9. So similarly, what is the cofactor of this element 8? So the cofactor that will be equal to minus 1 whole to the power 1 plus 1, and whatever the base we write here, the base we will write here. So minus 1 whole to the power 1 plus 1 and M11. So we write there A11 will be equal to minus 1 to the power whole square, and the value of determinant of B will be minus 9. So that will be equal to minus 9. The answer will be minus 9. So the minor of element A will be minus 9, and similarly the cofactor of element minus 8 will be 9. Similarly, we can find the minus and cofactors of every element. So similarly, what is the minus of this 0 element? So in this way we can delete this row and this column. If we delete this row and this column, the minor will be equal to 4, 7, 2, 5, and similarly the cofactor of this will be, we can find in the rest of the element. Similarly, we can find the minor of A13 element. Similarly, we can find the minor of A21 element, A22 element, A23 element, A31 element. So every element, from every element we can find the minors, and we can find the cofactors as well as. So this is the procedure to find the minors and cofactors of every element. So next one is, say, how to find the determinant of any square matrix. So as I told you, there are 3 ways, as I told you in my face-to-face class, to find the determinant of a square matrix. So as I told you, one method is the cofactor method. So with the cofactor method, we can find the determinant of the matrix. So here it says that the first method is determinant of a matrix by using the method of the cofactor method. So here it says that multiply each element in the row by the column matrix by its cofactor, the sum of the product of the determinant. So we can find the determinant by the cofactor method by two ways. In first way, we can solve by the column wise. In second way, we can solve by the row wise. As I shown you in my face-to-face class, in both the way we are getting the same result. There are no any changes. If for example, if there is a matrix is given, so either we can open the matrix by the row wise, or we can open by the matrix by the column wise. We are getting the same result. There is no change in the result. So is what it says, example of finding the determinant by the cofactor expansion. So let us take an example. It's here, there is a 3 by 3 matrix. 3 by 3 matrix is given here, and it says that find the value of the determinant. So solution, find the determinant of a, we select the row or column. Anyway, either we can go from row side, or we can go from column side. It's up to us. We can choose anyone, and we are getting the same result if whatever we choose. So let us choose. We begin with about the first column of A. Then so it says that we start from the first column. So that will be is equal to A11 and the minor of A11. Here it is right the minor only in A11, and the A21 the minor of A21. Similarly, the A31 the minor of A31. So here they are not showing what are the A11. So I will tell you here what is A11. So in this case the A11 will be -6, 7, -3 and 5. This is A11. And what is A21? What is A21? So A21, this element will be A21. So when I going to delete this column and this row and this column, so rest of the determinant will be 0, 4, -3 and 5. So this will be our A21. Similarly, we can find the determinant of A31. So A31 will be is equal to, if I'm going to delete this row and this column, the rest of the determinant will be 0, 4, 6, 7. So this is the determinant of I. So when they are going to solve this determinants, so they will find the value A11 will be is equal to -9. From the previous example they solved, I think previously they solved them. So the value of the determinant will be -9. Similarly, A21 they will get A21 they will get -12. A31 will get it 24. Now combining all these three here, so you will get the answer will be is equal to 72. So in this way we can find the value of the determinant. Either we can solve by the row wise or we can solve by the column wise. So this method is called the cofactor method. So hopefully you understand this method. Why we write A11? A11 means how you know that which element we are talking about. So the A11 means these are the names of that element. So that's why they are writing A11. So A11 here. So A11 here. What is the meaning of A11? It means 8. What is the meaning of A21? A21 means they are talking about 4. So what is the meaning of A3? A31. A31 means they are talking about 2. So there is the matrix. So every element has a name. So how do you know that which element we are talking about? So so it is a general rule. First element will be A11. Second element will be A12. Third element will be A13. And the second row first element will be A21. The second row second element will be A22. So this is a general rule. This is it is not everyone knows that it is a general rule of the matrix. So because of, if you don't know that, how we will know that which element we are talking about? So this is a general rule. So in this way we will get the 72. So hope you understand. Any question up to here? So okay, let's proceed. How to find the adjoint of the matrix? So adjoint means there is one more thing, there is adjoint. So it is useful when you are going to find the inverse. There is one more as I told you, to find the inverse, there are several methods we discussed in the last week class, week 2 class. But here there is one more method that is called the adjoint method to find the inverse from the adjoint method. So it says that adjoint method says that you will first of all you will find the cofactors of the matrix, and whatever the cofactors, you write all the cofactors over here. So for example, this is the cofactor of element A11, this is the cofactor of element A12, this is the cofactor of element A13, and rest of the elements you write the cofactors here. After that, you will take the transpose of this element. So you know that meaning of transpose, meaning transpose means the first row will become the first column, and you will convert first row into the first column. So let's see how we will write this. So here we write the first row in the first column. So observe that here A12 here, in the previous A12 was here. I am going to back. Let's see here, A12 here, so and A13 here. In the next slide you will see there A13 here and A12 here. And first row will become first column, so and second row will become second column, third row will become third column. So in this way, it is called the adjoint of the matrix. So so this is what we are going to do with the adjoint. We can use it to help us to find the A inverse if A inverse is inverse. So it is, the adjoint is one method to find the inverse of the matrix. So there are if you remember in the last week class, I told you to find the inverse there is a row reduction method. From the on the left side we write a matrix, and from the right side we write the identity matrix, then we apply the row operation until the left side will become the unit matrix. So that is one method. And another method I told you, if we have a 2 by 2 matrix, then we can convert it. For example, A B C D. If A B C D is here, then you will convert the matrix. You write D here and A here and minus B here and minus C here. So this is another method to find the A inverse. So this is the third method to find the inverse of the matrix. That is called the adjoint of the matrix. So the formula to find the inverse is A inverse is equal to 1 upon determinant of A adjoint of A. This is the formula to find the A inverse of the matrix. So there are several. A square matrix is invertible if only if A does not. This we know that previously. So this is the methods that we discussed. As I told you right now, this method is up here. This last week we discussed this method. If we have a 2 by 2 matrix, and if we want to find the inverse, then we will write this A is equal to 1 upon dA minus B minus C. A inverse will be equal to, and A inverse, this is the A inverse will be equal to like this. So evaluate the determinant of this is the matrix 2 by 2. What is the determinant here? It is a determinant. How to compute the higher order determinants? So if we have a 2 by 2, 3 by 3, 4 by 4, then what's the procedure to evaluate the determinant? So minors and cofactors, again they are showing. In the cofactors, we will keep in mind, first we will put the plus sign and the minus, then plus if we are going from the row wise. Similarly, if we are going from the column wise, same thing, first we put the plus sign, then minus, then plus. So in this way we will open the bracket. So in this way we are going to open. Here it is written as A11, M11, A12, M12 plus A13, M13. So these all things we understand, we read. So it's again they are talking. So if we have a 3 by 3 determinant expressed in term of 2 by 2 determinant. So similarly, if we have a 4 by 4 determinants expressed in term of 3 by 3 determinants. So now we are going to discuss the several properties of the determinants. So there are 6 properties of the determinants. So one by one we are going to discuss these properties. The property number 1 it says that if we are going to interchange any two rows or any two columns, then then the sign of the determinant is changed. For example, this is a determinant A, and if we are going to interchange this third column with the fourth column, then what happened here, we changed third column, fourth column will be second column, and second column will be fourth column. Here we interchange these columns. So what happened, the determinant is equal, determinant of A will be is equal to determinant of B, and put the minus sign over here. So whenever the one question we apply in my face-to-face class in this time, when I try to solve one question, so there is a point arise that when I interchange any two rows or two columns, the sign of the determinant I change. So this is the property of the determinant. So either we change the two rows or I change the two columns, then the sign of the determinant must be changed. So let's take another example. Here we are talking about there is a row 1 2,003, and there is a row 4 minus 6 224. So I am going to interchange these two rows. So here I changed these two rows. So what we observe, whatever the value of the determinant A will be is equal to minus sign of the determinant of the C. So this is one property. Either we interchange two columns or we interchange two rows, the sign of the determinant is changed. Similarly, property number 2, it says that whenever the two rows or two columns are identical or proportional, so the value of the determinants are 0. So here we observe that row 2 and row 4 are same. So we directly say that the value of the determinant are 0 because of here minus 3, here minus 3, here 1, here 1, and 5 and 5 and 4 and 4. So we say that the determinant, the value of the determinant is 0. Similarly, if we observe in these two rows, we observe that these two rows are same. So we say that minus 6 here, and 2 and 2 here, and 2 and 2 here, and similarly 4 and 4 here. So we directly say that the value of the determinant is 0. Now, property number 3 is also to say that ith row plus jth column, if I'm going to write, then the determinant of A will be is equal to the determinant of B. Similarly, in the case of row, we can also say that the determinant of A, both the rows are same, so we say that these two determinants are equal. Similarly, if I am going to multiply any determinant with any constants, like here the second column will be 0 and minus 1. If I multiply with column 2 with 5, so 5 zeros of 0, 5 multiplied by minus 1 will be minus 5, 5 multiplied by 4, 5 will be 20, and 5 multiplied by 2, 5 2 is 10. So it means when I multiply these two with the 5, then I can write determinant of A, determinant of B will be is equal to 5 times of the determinant of A. So wait a minute. So we are talking about if I multiply any row or any column with any constant, we have to multiply with the main determinants. So here determinant of B, if we multiply with 5, that will is equal to we have to multiply with the whole determinant. Similarly, here we have a determinant A, and if we multiply with determinant A by 3, so 6 3s are 18, so 6 3s are 18 here, and similarly 2 3s are 6, 2 3s are 6 here, and 2 3s are 6, 2 3s are 6 here, and similarly 4 3s are 12, 4 3s are 12 here. So it means we write that determinant of C will be is equal to 3 times determinant of A. So this is the one property of the determinant. And the property number 5 says that if we are saying that the ith row of B is equal to ith row of A1 plus ith row of A2. So we say that if we have a determinant, this is the determinant of B, so here will be minus 18, and here we are going to observe, if we are going to observe minus 12, and what will be the minus 6. So if we are going to add minus 12 and minus 6, that will be is equal to 18. So similarly, if we are going to add 4 and 2, so that will be is equal to 4 plus 2 will be is equal to 6. So 6 is here. Similarly, if we are going to add 4 plus 2, that will be is equal to 6. So 4 plus here 4 plus 2, and here is also 6. Similarly, if we are going to add 10 plus 2, 10 plus 2, that will be is equal to 12, and 12 is also here. So we can write that determinant of B will be is equal to determinant of A plus determinant of B. So similarly, we can write property number 5B, we can write in the form of column. The same thing is happens in the form of the column. So these are the properties of the determinant. So, and the property number 6 says that, as I told you, that this is the upper triangular matrix. Upper triangular matrix is that whenever the matrix we have this is the main diagonal, so all the elements below the main diagonal are 0, then we say that it is it is an upper triangular matrix. Similarly, all the elements below the above the leading diagonal are 0, then we say that it is a lower triangular matrix. So the property number 6 is that determinant of a triangular matrix, that is the product of the diagonal elements. So there is no need, if we have given a triangular matrix, either it is lower triangular matrix or it is upper triangular matrix, then what is the determinants? So you directly say that, for example, it is a 4 by 4 matrix is given. 4 by 4 matrix is given. So it is a property that it says that what is the value of this determinant. So it can be asked the question only in 1 mark, that what is the value of this determinant. So you directly say that the value of this determinant is just multiply the element of the main diagonal. That is, you will multiply 2 multiply by -1 multiply by 3 multiply by 4. So when you multiply is 4 3 is 12, and that will 12 to the 24, and 24 that will be minus. So you will get the answer of this determinant is -24. So it's only 1 mark question. So whenever, keep in mind, this is the property. It says that whenever we have an upper triangular matrix or lower triangular matrix, then only we multiply its diagonal elements. So let's suppose. So similarly, there are several more examples. Transpose of the matrix, it says that if we have a matrix, as I told you, transpose means you will convert the rows into columns. Here it is 1 2 3 is a row. Here it will be 1 2 3 will become column. Here it is the second row, it will become second column. Here it will be third row, it will become third column. So whenever this type of things happen, it is called the transpose of the matrix. Determinant, the property number 6 says that whatever the value we are getting of a determinant is equal to the value of the transpose of the matrix. There is no interchange. For example, we are getting the value of the determinant. For example, we are getting a 20 answer. So here again we are getting the value with 20. So there is no change if we are taking the transpose. In both the way we will get the same result. So determinant of A will be is equal to determinant of B. There is no any change. We are talking about the determinant, everything we are talking about the determinants. So matrices and determinants, most of the things are same, but if we have a matrix in a square, if we have a square matrix, then we say that it is a determinant. So determinants is only for, as I told you in the very first way, determinants is only for to find the inverse of the matrix. So there are very similarities between the determinants and the matrix. So determinants are always a square, but the matrix can never be. But the matrix can be or cannot be a square matrix. So there are several properties of the determinant of the property is A transpose, whole transpose will be equal to A, and if we are going to multiply any constant with the A, that will be transpose, and constant will be outside and there will be transpose. So there are several properties. So these are now next thing is the Cramer's rule. We are going to discuss the Cramer's rule. So Cramer's rule says that when we have a system of equations like equation number 1, equation number 2, equation number up to n, then it says that to find the value of x1, x2, x3 with the help of the Cramer's rule. So we can do it by x1 will be is equal to determinant of a1, as I told you in my face class, determinant of a1 upon determinant of a, and similarly the value of x2 will be is equal to determinant of a2, upon determinant of a. Similarly, up to n xn will be is equal to determinant of an upon determinant of a. So in this way we can find the value of value of x1, x2, x3. So let us take an example of the Cramer's rule. So here there are three equations are given: x plus 4y plus 5z is equal to 1, and equation number 1, equation number 2, equation number 3. So we are going to solve. Okay, this slides again appear. So here the Cramer's rule, it is given here. So let's we take an example of the Cramer's rule. Here there are 2 by 2 equations. Equation number 1 is given, and this is equation number 2 is given. So we have to find the value of x1, x2, x and y with the help of the Cramer's rule. So first of all, I will write the value of determinant of a. So determinant of a will be is equal to, the coefficient of this equation. So coefficient of x will be 1, the coefficient of x will be 2. So I write the coefficient of x1, that is, and where is the a and 1. We can write the determinant of a will be is equal to 1, 2, and 4 and 9. So I write the determinant here. So here it is, they are replacing the name, basically it is a. A will be is equal to 1, 4, 2, 9. So just we multiply it. 9 was a 9 minus 4 to the 8, that will be is equal to 1. Similarly, we will find the a1. So in a1, so we replace the column 1 with the right hand side. So in place of column 1, we will put 3 and 5. 3 and 5, we will write 3 and 5 here. So the a1 will be 3 and 5, and 4, 9 is same. So I write 3, 5, where is this is a1. They are writing a1. This is a1. So they are putting e. So similarly, a2 will be equal to just putting the first column as same, and in place of second column I will put the right hand side. So first column will be 1, 2, and the second column will be 3 and 5. So I write here this is a2. So a2 will be is equal to this. So here a1 and a2. So these are the value of the determinants a1, a2, and a. Now to find the value of x1, x2, x3. So let's see. The value of x1 will be is equal to determinant of a1, upon determinant of a. determinant of A. So we will put the value of, here they are using different numbers, so you will get a 7. Similarly, the value of y, we are getting the determinant of A2 will upon determinant of A, so you will get -1 here. So this is the procedure to solve the value of x and y through Cramer's rule. So in my face-to-face class, I discuss a 3 by 3 exam matrix, but here we are using a 2 by 2. So you will see them. So the last topic is evaluate the determinants by reducing the matrix by row echelon form. So we can find the determinants by a row echelon form, yani by row reduction method. So let's take an example. It says that this is a square matrix, and we will convert this matrix into this form, yani 1 0 0 and 1 0, and this will be 1. So if we convert this matrix into upper triangular matrix, then we can find the value of the determinants very easily. So by the help of the row reduction form, row echelon form, we will do the process again and again. As I told you from the very first day, that we will use this type of procedure in whole of the semester. So you have to remember how we can apply these things. So here what we do, here first step is we interchange the two rows and row 1 with the row 2. So when we are going to interchange, there will be a minus sign. So we put a minus sign here and interchange the two rows. And similarly, again and again, I will apply. Our aim is first element, with this element will be 0, so we apply this will be 0, and the next aim is I want in this in place of 3 we want 0. So again we apply the row operation. Here everything is written, you will read at your home how we apply. So this will be 0. So our next aim is I want in place of -1, I want to remove it, and so we will remove this here, and lastly we will remove -5 by 3, and that will be is equal to this. This is an upper triangular matrix. Finally we will convert this is into upper triangular matrix. So hopefully all of you are aware about how we can convert. If you don't understand, then just go back to the previous week. In detail I told you everything about this. So we will convert it into the upper triangular matrix. So what is the value of the determinant? The value of the determinant is -3 multiplied by -5 by 3 and multiplied by 1, because of, as this is the property of the determinant, whatever the diagonal element is called the value of the determinant. So when you multiply, you will get 5. So that's the end of your today's lecture. If you have any question, then ask me. Yes, tell me, Suleiman. Yes, we can take in determinant, we have take the common. Where 1 by 3? Where we take the 1 by 3? As I told you that whatever you can apply the operation. Our aim is I want 1 0 0 and 1 0 and 1. So any method you can apply. Either you multiply with 3, divide by 3, add by 3, subtract by 3. So whatever the method you apply, it's up to you. Either you divide or multiply, but the final aim is same. For, for example, if you are going from Riyadh to Jeddah, so there are several ways are there. Either you can go from via Medina, from via Mecca, from via other several. There are several ways. So it's up to you. But the final destination is same. So that's why it's up to here. There is no any problem. Okay. So you will read it. You will try to solve at your home. Then you will understand how we can solve these problems. Okay. So okay, I will upload these slides tomorrow. You can find it on the blackboard on extra resources. Yes, you can find on the, as I told you, there is a folder extra resources. You will find them and you can download them from there. Okay. Have a nice day and good night.